Okay, so we're continuing today, and today we're doing section 10.5, which is parabolas. Now, parabolas can be, you've done them before, so you've done them where they either open up or down, but today they're actually going to open sideways as well. Okay. Section 10.5, go ahead and copy this down. So now you're writing this down in your notes. You already know is a parabola, and go ahead and write it on this side because I'm going to write some notes over here. You know that you have your vertex. You also have what is called a focus point inside of your parabola, and that you haven't done before for parabolas. So we're going to have this as your focus point. You already know that you have an axis of symmetry. And that'll be an equation of a line. This part might be new to you. The distance between here and here, you're going to calculate it, and that is a distance of P. The same distance from your vertex inside the parabola will give you your focus point. The same distance from your vertex, P distance outside, is what is called a directrix, and that's also an equation of a line. So this would be an equation of a line called your directrix. Now you can have a parabola opening up and down, and that's what you've done before in previous classes or courses. So that's like an x squared. Now you're going to have parabolas that actually open, to the left or to the right. The equation for this one is going to be one where you have your x squared. The equation for this one is one where you have your y squared. And h and k give you your vertex. And again, it's the opposite of what you think. The only other new term that's variable right here is for p. They'll have a coefficient, and you'll have to solve for your p value. And again, the p is the distance from here to here, the same distance here as the same distance here. If you have a positive p value here, it's going to make your parabola open up to the positive side. If you have a negative p value, it'll make your parabola open down. And same thing here. If you have a positive p value, it opens up to the positive side. A negative p value, it'll open up to the negative side. All right, let's do a problem. So our first problem we have, go ahead and copy that down. These are actually not too bad to graph. You just have to find all the information. So x minus 3 squared equals 8 times y minus 1. First thing you're going to do is you're going to find your vertex. So your vertex, is opposite of 3, opposite of 1. So it is 3, 1. Go ahead, draw your axes at 3, 1. You know it's an x squared, so you know that your quadratic is either opening up or down. So the only thing you have to figure out is your p-value. So if you look back at your formula, you would notice that, right here. This is this problem, so it's x squared, it's opening up or down, and you're going to set this term equal to 4p. So this number right there, set it equal to p and solve it. Divide by 4. Your p-value is 2. So that means because it's positive, it's going to be opening up. Well, if you know this is your vertex, you can kind of already draw it as you need to. That's fine. They actually don't pick other points. You know it's opening up. So we can go ahead and sketch that. And don't worry about finding these actual points, that's fine. So what we do need to know is this. This too is going to help us find the other information. So 2 units from your vertex inside gives you the coordinates of your focus points. So the focus point is at 3, 3, so that's a distance of 2. 2 units back is going to give you your equation of your directrix. So because it's an equation of a line, this is going to be a y equals -1. So again, that is your P units. You don't have to label this, but that is that distance. This is 2 units and 2 units. You also have one more piece of information, which is your axis of symmetry. And your axis of symmetry is, you would already know where that goes. And again, because it's a line, it's an equation of a line. So your axis of symmetry is at x equals 3. Okay, problem 2. Or did I finish the last one? So the axis of symmetry for that one was x equals 3. Okay. Problem 2. So same thing, except it doesn't look anything like this because this is in general form and we want to change it to standard form. So again, we're going to go ahead and complete the square. Get your y's together, get your x's together, So on this side, because the y squared is positive, I'm going to keep the y's here and you're actually going to move your x's and your other number to the other side. Minus the x minus the 18. You're going to go ahead and complete the square for this. So you remember how to complete the square is half your middle term squared. Half of -8 is -4. -4 squared is +16. Whatever you do to one side, you do to the other side. Go ahead and rewrite this as a perfect square. So this looks good. If you go back to your notes, you're supposed to have this in, let me find them. So this should look like it's a y squared, so we're looking at this one. This should be in parentheses, so the only thing I'm going to do is I'm going to factor out a -1. And you'll see why I did that in a minute. Okay, so now I have it in the right format. I'm going to find all the correct information. So my center is at the opposite of the one with your x, -2. The opposite of the one with your y, +4. So I quickly drew an axis over here, right there. And your center is at -2 up 4. So there you have your center. I have to find my p-value. You know, because it's a y squared, that this graph is going to be opening left, right. So what would your p-value be, or how would you find it? The p-value is always the number that goes here. You're going to use that to set up your equation. So your equation is going to be 4p equals -1. Solve it for p, so divide by 4 on both sides. Okay. The 1/4 tells you the distance. The negative tells you that it's going to be opening left and right, and because it's negative, it's opening to the left. So if this is your vertex, your focus point would be 1/4 of the ways in here. Your directrix would be 1/4 of the way out there. Your axis of symmetry, well, let me just draw this. And right now, I'm not showing you how wide. Just go ahead and just know that it's going to be that shape. You would actually have to take points in and plug them in to figure out how wide. Okay, so I'm going to go ahead and label all of these points. All right, so I went ahead and drew my axis a little bit better. So we know that our vertex is -2, 4. I put center. It's not a center. It's a vertex. Your vertex is at -2, 4. Your distance 1/4 away inside gives you your focus point. So that's -2 1/4 up at 4. Your directrix is back 1/4, and that's an equation of a line. So that's going to be at -1 3/4. X equals, because it's crossing the x-axis. Axis of symmetry is going to be this line right here. So that is y equals 4. So that's all the information that you would need. Okay, problem 3. Again, it is in general form. That's not going to help me. So I need to move things around, complete the square so it looks something like standard form. Get your x's together. And again, how do I know what to keep here? Whatever is squared is the one that you're going to want to keep on the left-hand side so that it goes to the formula. So whatever you have squared, keep it on the left-hand side and then move the other one to the other side. So I'm going to keep the x's here and move this to the other side. So I went ahead, kept the x's here, moved this to the other side. I'm going to complete the square. Half of -4 is -2. -2 squared is +4. So I'm going to add 4 to both sides, rewrite this as a perfect square. Looks good, except I want to have something out factored here. So I'm going to see if they have anything in common that I can factor out, and you can factor out a 16. Okay, so now it's in the right format. I'm going to find my vertex. Your vertex is, again, the opposite of your x. +2, opposite of your y, -2. So your vertex is at 2, -2. I'm going to, before I even graph, I'm going to go ahead and find my p-value. We know that we're going to use this number for our p. So we're going to set 4p equal to 16. And again, it's always 4p because that's what it is in the formula. So 4p would equal to 16. Divide by 4. All right, so now I'm going to go ahead and kind of quickly graph my vertex at 2, -2. Okay, so graphing everything, I have my vertex at 2, -2. So I know, and it's your p-value is 4, so 4 units inside, 4 units outside. It's positive, so you know that your parabola is going to be opening up. So it looks something, again, I don't know where it's crossing. I'm just going to get the general shape of it. So your focus point is 4 units inside. So that's at 2, 2. Your directrix is 4 units outside of it. So that is at y equals -6. Your axis of symmetry is going to be at x equals 2. Okay. And that's all the information.